Hi guys, this is MERILIN FITORIA, and today I will be presenting what is 7.2 trigonometric integrals. So the goal for this section is to integrate products of power of trig functions. In this case, I wanted to write the integrals that we should be memorizing at this point. And I think it's an important part for this section, so that's why I wrote it down. So as we know, we have sine x dx equal to negative cosine of x. Cosine of x dx equal to sine of x, and so on. In this section, we have two types. We have type 1 and type 2. I'll be explaining a little bit more of them and developing more information about it throughout this video. So we have type 1. Type 1, it's sine to the power m x cosine to the power n x dx. And type 2, which is tan to the power m x secant to the power n x dx. Also, in this section, we have the most important or very important in this section, which are the identities. We have first the Pythagorean identities, which is sine square x plus cosine square x equals 1. We have tan square x plus 1 equals secant square x. And we have also the half angle identity, or also well known as the power reduction, which is sine square x equal 1 negative cosine 2x over 2 equals to 1 over 2 negative 1 over 2 cosine 2x. And cosine square x equal 1 plus cosine 2x over 2 equals 1 over 2 plus 1 over 2 cosine 2x. So it's kind of the same thing, but just the signs, it's negative and positive. Just going back to the Pythagorean identities, one important thing to remember is that sine can be expressed as a cosine if you have an even power, as cosine can be expressed as sine if you have an even power. And for the half angle identities, one important key to remember is that a half angle identity takes a second power and reduces down to a first power. So I already wrote down some of the steps for type 1. So as we know, we have the equation, the formula right here. And these are the steps. So step number 1 is to peel off any trig function that has an odd number. So I just highlight the peel off an odd number because that's the key. That's the key to figure it out if we're gonna use type 1. So I just circularized number 3. I put number 3 right here just to give an example of what an odd number is and like how we can use the formula. So I'm gonna just put odd. So by saying peel off, I'm gonna show you the way we're gonna do it. I'm just gonna write it right here. So we just put sine m x cosine, let's say we have 3, right? So instead of 3, instead of 3, we're gonna use 2 times cosines, and we leave it like that because that means it's 1 dx. So that's the part of peeling it off. So the second step is to use the Pythagorean identity to convert all other signs to cosines. So in this, so what we're gonna do is just to bring this down to convert sine to cosine. So I put sine squared just to so we don't get confused with this part. Okay, so let me just do it right here. And what we're gonna do is just put sine, not integral. So it's just gonna be sine square x plus cosine square x equal to 1. And then we put cosine square x equal to 1 minus sine square x. So this part right here, let me fix that. So this part right here, we're gonna replace it, and then we're gonna put it in a new integral. So the way we replace it is just to put sine square x parentheses 1 minus sine, you see where we put it? X cosine x dx. So that's step number 2. So we convert sines to cosines. Or it can depend, it all depends on the problem that we have. It depends on that. Okay, so now we go to the last one, kind of last one for this section, if we can say it that way, which is number 3. So for that one, it's letting u be sine of x and du cosine x dx. And then we integrate. But for that one, like I was saying, it all depends on which integral has an odd number. Okay, so here we're gonna use integration by parts. After that, right after selecting u, du, we're gonna integrate. So to put that, we're gonna put u squared parentheses 1 minus u squared du. And then we can, follow the same process. So it will be u squared du. We already know what's du. Let me just highlight. So we have du, and then du is this. And then we have u. So we have u, and then u is this. We kind of put everything we have in the equation so we can figure it out. So let me just finish this. So we have 1/3 u to the third minus 1/5 u to the fifth plus c. So as we know, we have been hearing this throughout the whole chapter, that we can never leave a u into our answers. So we have equal 1/3 sine to the cubic x minus 1/5 sine fifth x plus c, and that will be our answer in this part. And that's the way we use the last step right here. And that's pretty much okay, so for type 1, I'm gonna make a quick example for this, just to make sure we're clear and just to understand this section a little bit more. So for this part, we have 4 sine squared x cosine to the third x dx. So, okay, so how we're gonna figure out, like I was saying, we have the odd number, which is 3, and then the first step is to peel off. So the way we're gonna peel off is like I was explaining before. So we put 4 sine squared x cosine squared x times cosine x dx. So we already did what is the first one, the first step. So our second step in this section is just to convert, right? We're gonna convert sines to cosine or cosines to sine. So we have in this little corner, I'm gonna put cosine squared x equals to 1 minus sine squared x. Cosine squared x, sine squared x minus 1, which is almost kind of the same thing, right? Okay, so now after that, we're gonna put it right here. Then we're gonna put a 4 sine squared x, and then we're gonna replace it, like I was saying, with sine squared. We can just do it, let me just fix it like I was explaining before. So it's 1 minus sine squared x. Okay, and then we're gonna multiply cosine x dx, just to put this part down there. Okay, so after that, what we're gonna do is just use the u's. We're gonna integrate. So the way we integrate, we're gonna put forward. Okay, so like I was saying, it's just forward. we're gonna put it out of the parenthesis, which is gonna be like 4u squared parenthesis u to the 4 minus, it's not, I mean u, that part, minus 1 du. And then so we're gonna figure out which one is u and which one is du. So u is gonna be sine x and du is gonna be cosine x dx. So after that we're gonna follow, and then we're gonna put 4 1/3 sine. Also remember that we're gonna, like, I like saying, like, we're gonna add 1 power to the exponent. So you know how we have a 2 right here, and then this became 3. So the way I understand it is that we add like 1 number into that, so we can keep integrating this part. So it will be x parentheses 1/u sine to the 4 x minus 1 cosine x dx, because that's the du we have right there. So this will be equal to 4 sine x over 3 minus 4 sine x to the 5th power over 5 plus c. And that will be our answer for this type 1. Okay, just to clarify, I forgot to put the 3 right here. I was just checking if my answer was right. So yeah, it's just 4 sine x to the power of 3 over 3 minus 4 sine x to the 5th powered over 5 plus c. Okay, so for type number 2, it's kind of the same thing. It's just a little bit different. So as you might see or notice already, we have secant and tangent instead of cosine and sine. So we have the formula right here, which is, let me just, so you guys can see. Okay, so we have secant n times, or x, I mean, tangent to the power of mx dx. That's how you have it. Okay, so the first step is to pull off secant squared. Why? Because this one, it's even. So it's kind of the same thing. So instead of having an odd, we're gonna use an even power, right? So after that, we're gonna use the Pythagorean identity to, so secant squared x becomes tangent squared x plus 1. Not become, but it's equal to tangent squared plus 1. To convert all other secants to tangents, kind of the same thing that we were working on type number 1. You got it? Okay, so the third step is to let u be equal to tan x, and du, it will be equal to secant squared x dx. So I'm going to put it back. So just an important part in this section is this. If m is odd and n is greater or equal than 1, we're going to use kind of the same step, but a little bit different. So same thing, we're going to put 1 will be peel off secant x tan x. We're going to use the Pythagorean identity. So it will be tan squared x equal to secant squared x minus 1 to convert other tangents to secants. And then the third one will be u equals to secant x du equals to secant square x dx. And then last will be to integrate. Okay, in this section, just let me do one example. So we're gonna make this video a little bit longer and I don't confuse you guys more. So we have, let's make this number 2. And then let's make, let me see, 1. Tangent, cubic. This is the one we're gonna be working on. Okay, so what we're gonna do, we're gonna peel off any of the trig functions. So we're gonna use this one because this one is odd. We're gonna use type 2, by the way. So we're gonna use this one right here. Let me just highlight it. We're gonna use type 2 to solve this problem, okay? So we're gonna use that, and then we're gonna peel off, right? So we're gonna put tan squared x times secant x tan x dx. So we know right here, let me just put it in another color. Tan square x equal to secant square x minus 1. And then after that, you guys got it? I hope you guys did. So after that, we're gonna use, it's gonna be equal to, we're gonna do the second step, which is the Pythagorean identity. Or we already did, right? Sorry. So what we're gonna do is just, let's find out which is u and which one is du. So let me just write it down right here before we move on to step 3. So it'll be secant, because tangent becomes secant. Okay, so what we're gonna do is just put secant squared x minus 1. Remember, we're gonna replace it like we did in type number 1. And then we're gonna put secant x tan x dx, which will be equal, remember, we're gonna figure out which is u and which is du. So u will be equal to secant x, and du will be equal to secant x tan x dx. Okay, so we're gonna put it right here. It's gonna be u squared minus 1 du. This is the integration by parts. Equals 1 over 3 u 3 minus u plus c. And then remember that we can finish this having u's. So we're gonna put 1 over 3 secant 3x minus secant x plus c. And we can leave it like that, and we're gonna have our answer like this. Same. And actually that's kind of all for this section. I just wanted to make like a summary of it, because like a review, because most of us understand this topic and it's a topic to remember.